In this video, we're going to work example problems where we simplify I raised to some power, specifically an integer power. And it's important to know how to do this because you shouldn't have a simplified expression that contains I to some power other than 1, because you could always simplify it. So we want to see how you can do that. Now, just to point out, the idea of if you have I to a negative integer power, something like this, well, you can simplify this in the same way that if you know how to simplify I to positive integer powers, you can simplify this easily, because this is just 1 over I to the 20, right? And I to the 0 is going to be 1 for the same reasons that any number to the 0 power is 1. This is just, if you have like I squared, I cubed, you're multiplying by I, right? But if you go in the other direction, you're dividing by I. This is I to the first. But what would be next in line would be I to the 0 divided by I. What's I divided by I? That's 1. Right? And then you keep going, divided by I again. That's going to be 1 divided by I. But that's, if we keep with the exponential form here, we keep the pattern going. You see? So, okay. So the way you do this is you're just going to, you want to separate the power up into, there's going to be the largest factor of 4 that's there with some remainder between 1 and 3. So the reason why we're going to do this, like in other words, okay, so 25, you divide 25 by 4. Okay, well 6 times 4 is 24. So, okay, it's 6 with a remainder of 1. The remainder is always going to be something between 1 and 3, right? Because you're dividing by 4. So with that, then you say, okay, well, you write it this way. You write this as, this is I to the 6 times 4 is 24 times just I to the first. And well, the advantage of this is that we know that I to any power that's a multiple of 4 is going to be just 1. And so we're left with that this is I. That's the big idea. And so, but we're going to be left with, for any problem, you're going to have I to the first, I to the second, or I to the third. Well, we know, okay, I to the first is just I squared is -1, I cubed is going to be -1 times I, so negative I is to the first is just I, and then I to the fourth is going to be 1, and then that pattern repeats. I to the fifth is going to be I squared -1. So that's why it works out to where any multiple power of I that's a multiple of 4 is just going to be 1, and we take advantage of that. Okay, so I to the 22nd, well, we know that 4 times 5 is 20. So write this as I to the 20th times I squared. I to the 20th is 1. I squared is -1. That's the answer. Okay, well, 4 times 5 is 20. So we have I to the 20th times I cubed. This is 1. I cubed we know is -I. Okay, we know that 8 times 4 is 32. So this is just going to be 1. 32 is a multiple of 4. Okay, this is not an issue because we just write this as 1 over I to the 13th. Okay, now 4 times 3 is 12, so this is going to be I to the 12th times I. I to the 12th is 1, so 1 over I. Now, we can actually continue to simplify this even further, which we should, because we can say it's like we're dividing 2 complex numbers here. It's like 1 plus 0I divided by 0 plus 1I. So we do I divided by I, and you're left with I. It's kind of like rationalizing. I over I squared, which is I over -1, which is -I. Okay. This we know this is just I to the 11th, right? So let's see. You have I to the 8th times I cubed. Okay. I to the 8th is 1. I cubed is negative I. Okay. I to the 26th. We know that 6 times 4 is 24. So times I squared. This is going to be 1. So we have I squared. So this is negative 1. Okay, now let me give another example with a something like I to the 5,133. Okay, what would this be? Well, we just do 5,133 divided by 4. So 4 times 2 is 8. 8 times 4 is 32. 4 times 3 is 12. So we have a remainder of 1. So we can write this as, what this is going to be is 12,000 or 1,283 times 4 is going to be 5,132. We can verify that. 32, 33. Yeah, you see? So we can write this as there's the remainder of 1, you see? Well, this is a multiple of 4. This is going to be 1. See?